Okay, we have one of these tables that you're going to become quite familiar with here in Chapter 5. And this particular question is fun, and it shows a neat property of these contingency tables. So you notice that we do have the bottom row is a totals row, and the last column is a totals column. So that's how you'll identify one of these charts. You may have more than 4 squares here in the actual individual data points there. So how can we do this? Well, first of all, it's important to know how this operates. So anything in a total column, including this final number, is the total of everything in that respective row. So 70 is the total of these two, 148, which you wouldn't know to start off with, but is the total of these two, and 218 is the total of these two. Similarly, any in the total row is the total of that column. So 143 is the total of these two, 75 is the total of these two, 218 is the total of these two. So it even works for the total column and the total row. And your total number of people in the study or units in the study will be right here in the bottom right. So how do we figure this out? Well, first of all, I notice that this blank right here, I have everything in that row except this blank. So I know the total is going to be 70. I know that 70 is going to be whatever this is plus 44. So I can either subtract 44 from 70, or I could set up an equation x plus 44 equals 70. But either way, I can solve to get 26. Once I have that, I now have these three and this one and this one. I could have easily gotten this one first because I know that whatever this number is, these two numbers have to total up to 218. So similarly, I could take 218 minus 70 to give me the 148, or I could say 70 plus x equals 218, solve for x. Whichever way I do it, I'll now get that. The more you fill in this chart, the more options you have. So I could, since I have this one, I could go down and get this. Since I have this 148 and the 117, I could subtract to get this middle number. So of course, do both of those. That will leave you with this one. You can either add these two to get your 75, or you can take your 218 minus the 143. So if you have all of the data units, everything except the total, you can just add across or down. If you have the total and all but one of the data units, you can subtract to figure out what that entry should be. And then we have a question, what is the probability that a student randomly selected from this class, so how many students are in this class? That's where we go to the total down there, 218. So randomly selected from this class doesn't receive financial aid or doesn't own a laptop. So what does that mean? Doesn't own financial, or doesn't receive financial aid, or doesn't own a laptop. So this or is key here. In fact, it's huge. If we said and, we would have doesn't receive financial and doesn't own a laptop would be 31 students. If it had to be both of those, we'd have 31 over 218. However, it says or, and that, in other words, it means we could be in this column, because in this row, anyone in this row does not receive financial aid, or it's also okay if we're in this column, because anyone in this column doesn't own a laptop. So we have to add up the 117, the 131 to get 148, and this to get 192, and we put 192 over 218, and that should give us the final answer that we're looking for. So let's just double check that. 192 divided by 218, and we do get 88.1% because we're rounding to one decimal place.